Hey guys, in this video I'm going to run you through all the solutions for the AQA A-Level Paper 2 for 2024. Every question is going to be time-stamped so you can easily jump to a particular question or rewatch it if you need to. Hope this helps. Okay, so starting straight from question 1, it says one of the equations below is the equation of a circle, so we know that should be of the form x minus a squared plus y minus b squared equals r squared. Well, first off, the radius squared has to be positive, so it can't be this guy or this guy. And then it's specifically a plus in the in-between bit, so this guy can't work either. So it's going to have to be the last option. Moving on to question 2, it says the graph of y equals f of x intersects the x-axis at minus 3, 0, 0, 0, and 2, 0, as shown in the diagram. The shaded region A has an area of 189, and the shaded region B is an area of 64, but noticeably A is above the x-axis, so it would be calculated as a positive area, but B is below the x-axis, so it would be calculated as a negative area. And then they're doing the integral from minus 3 to 2, so if they do this in all, like they're trying to think about this integral all in one go, the A and the B are actually going to cancel out. So the final answer, like the area, or the value you'd get from the integral rather, would be 189 minus 64. So if we check what that is, that's 125, so it's the third option. Moving on to question 3, it says solve the inequality 1 minus x times x minus 4 is less than 0. So to solve an inequality, I'll always draw myself a little sketch. So that this quadratic is going to have a root at x equals 1 and x equals 4. And importantly, because of this minus x here, it's going to be a negative quadratic. It's going to look like this. And we're interested in where it's specifically less than 0. So that's everything to the left of 1 and everything to the right of 4. So we want x is less than 1 and x is greater than 4. And we want it can be, it's an or statement, right? Because it could be less than 1 or greater than 4. It's not going to be both. You can't be both. That would be a union, which means it's going to be the first option. Going to question 4, it says use logarithms to solve the equation 5 to the power of x minus 2 equals 7 to the power of 1570. So I'm going to pick log base 5. That's going to make it slightly nicer on the left-hand side. So I'm going to take log base 5 of both sides. That would give me this. And then using the power rule for logarithms, I'm going to bring down the power. So that would leave me with x minus 2 times log base 5 of 5. And we actually need to do this on the right-hand side. 7 to the power of 1570 is a huge number. So our calculator wouldn't actually be able to process that anyway. And then log base 5 of 5 is just 1, because 5 to the power of 1 is 5. So that leaves us with x minus 2 on the left. So if I just add 2 to both sides, we would get x would be 2 plus 1570 times log base 5 of 7. And then we want that as a decimal to 2 decimal places. So if we grab our calculator here, we're going to do 2 plus 1570 log, 570 times log base 5 of 7. Which is 1900.23 to 2 decimal places. Going to question 5, it says, given that y equals x cubed over sine x, can we find dy by dx? So that's going to be using the quotient rule. So the quotient rule, if we just write it out quickly, if we have u over v differentiating, it becomes v times the derivative of u minus u times the derivative of v all over v squared. So u is x cubed, meaning the derivative of u is 3x squared. V is sine x, and then the derivative of v is cos x, and then just substituting into the formula, we'd get dy by dx must equal v times derivative of u, so that's 3x squared sine x minus u times the derivative of v, which would be x cubed cos x all over v squared, which would just be sine squared of x. Okay, so moving on to question 6, it says we've got this trig equation. We're told that theta is obtuse, hence find the exact value of sine theta. Well, to start solving, we've got no option but to expand the brackets. So expanding the first bracket, we're going to get 4 sine squared theta. Then 2 lots of 2 sine theta times 3 cos theta, so that would be plus 12 lots of sine theta cos theta. Then 3 cos theta all squared, so that would be plus 9 cos squared theta. And then the second bracket, we're going to get 36 sine squared theta. 2 lots of 6 sine theta times minus cos theta, so that would be minus 12 lots of sine theta cos theta. Plus minus cos theta all squared, that's just a cos squared theta, and that's all equal to 30. Then the cross terms actually cancel, as it turns out, and we can collect the sine squareds and cos squared, so that would be 40 sine squared theta plus 10 cos squared theta. Is equal to 30. And then we can use the identity that cos squared theta plus sine squared theta equals 1, so I can split up this sine squared theta into 30 lots of sine squared theta plus 10 lots of sine squared theta plus another 10 lots of cos squared theta plus 30. And then this guy is just 10. It's 10 lots of sine squared plus cos squared, so we take that over the other side, then we'd have 30 sine squared theta equals 20, or sine squared theta equals 2/3, or 20 over 30, and then we square root, so then sine theta would be plus or minus root 2 over 3. Let's rationalize the denominator quickly, so if I times the top and bottom by root 3, that would be the same as plus or minus root 6 over 3. And then we have to decide which one we want. So if theta is obtuse, that means it's bigger than 90, so it's not an acute angle, but it's smaller than 180, so it's not a reflex angle. So we need to think of what value of theta would that make sense with our sine graph. So if we look at the sine graph, it's like if you take a negative value, it's always going to be a reflex angle over here past 180 degrees. So it's going to have to be the second solution, the theta, for when it's positive. So that's when sine theta is actually just the root 6 over 3. Going for question 7, it says on the first day of each month, Kate pays £50 into a savings account. Interest is paid on the total amount in the account on the last day of each month. The interest rate is 0.2%. At the end of the nth month, the total amount of money in Kate's savings account is £10, and she's correctly calculated the first 2 installments of her interest. It says, can we calculate the third installment? Well, we can just use the same calculation that she's done. So in her third installment of interest, it's going to be whatever she had in her account on the previous month, so that'd be T2, plus the extra £50 she puts in, times her interest rate, which is still the 1.002, increase it by 0.2%. And then if we think about, well, we know what T2 is. T2 is T1 plus 50 times the 1.02. Yep. 002 plus another 50 times the 1.002. So if we just take our time a second, actually expand this out for a minute. So we'd have T1 times 1.002 times 1.002 again. That's 1.002 squared. Then we're going to have a 50 times 1.002 squared. And a 50 times 1.002. And if we backtrack once more and plug in the T1 value for that she did before, so 50 times 1.002, we are going to get the same thing that they asked for. So 50 times 1.002 cubed plus 50 times 1.002 squared plus 50 times 1.002. Kate uses a method to correctly calculate how much money she can expect to have in a savings account at the end of 10 years. Find the amount of money Kate expects to have in her savings account at the end of 10 years. Okay, well, first off, notice it's changed from years to months. Sorry, from months to years, excuse me. So we have to think about, well, 10 years is 120 months. So after 120 months, and then using this process to go all the way to the 4th month is going to be kind of laborious. So let's actually analyze what's going on here, see if we can generalize this. So if we look at this, we can see we've actually got an arithmetic sequence going on. We've got 50 times 1.002, 50 times 1.002 squared, and then times 1.002 cubed. So that's a geometric sequence if you think about it, where the first term is 50 times 1.002, and the common ratio is going to be just the 1.002 again. And if we want the 120th month, what we're doing is we're summing this sequence. So we want the sum of 120 terms of this sequence to get the amount in her account after 120 months. That would be a 1 minus r to the n over 1 minus r, which is going to be 50 times 1.002, times 1 minus 1.002 to the power of 120, all over 1 minus 1.002. So if we compute that sum, or that formula, so 5 times 1.002, open bracket, 1 minus 1.002, all to the power of 120. Oops, to the power of 120. Close that bracket, and then it's 1 minus 1.002 on the bottom. Gives us 6,787. And do we want to round this at all? It doesn't say, so let's call it, let's do it to the nearest pence, so that would be 16 pence. So £6,787 and 16 pence. Then for B part 2, it says the amount of money in Kate's savings account at the end of 10 years may not be the amount she has correctly calculated. Explain why. Let's see what they said. So, it's a bit niche, I suppose, but interest rates aren't normally consistent for 10 years, so they'll fluctuate. So I would go with that. Interest rate likely to change over the course of 10 years. So whenever you get one of these comment on the model type questions, make sure you go back and read the model, and that will normally give you a bit of inspiration for how to comment. Carrying on to question 8, it says, a zookeeper models the median mass of infant monkeys born at their zoo up to the age of 2 years. So we've got an equation. Y is the median mass in kilograms, X is the age in months, and then we've got some data. So the zookeeper has used the first pair of values to find this equation, and then we're asked to use the second pair of values to get another equation. So just simply plugging them in, we'd have 12 would equal A plus B lots of log base 10 of 24. Then they've asked us to show that B is 5.6 over log base 10 of 8. So we've got two equations now with two variables, so we can solve simultaneously. So if I subtract one equation from the other, let's subtract their equation from mine, then we'd get 12 minus 6.4 equals A plus B log base 10 of 24 minus A minus B log base 10 of 3. So obviously the A's cancel, that's why I've done this. Then on the left, what would we have? We'd have 5.6 left. And on the right, if I factorize out the B from the logs that are remaining, we'd have B log base 10 of 24 minus log base 10 of 3. And if we recall our rules for logarithms, if we have two logs subtracted, it's the same as division of the insides of the log. So 24 divided by 3 is 8. We'd have 5.6 is B times log base 10 of 8. So just dividing over now, we get our answer that they wanted, 5.6 over log base 10 of 8. Then it says, find the value of A, give your answer to two decimal places. Well, we have our value of B. To get A, we can just simply go back and rearrange. So if I use the first equation, the 6.4, then we would get A is 6.4 minus B times log base 10 of 3. And we can plug in our value we got for B, so that's 5.6 over log base 10 of 8. 6.4 over log 6.4? Sorry, 5.6. 5.6 over log base 10 of 8, all times log base 10 of 3. And then they want that to two decimal places, so let's use our calculator to solve that or compute that. So 6.4 minus 5.6 over log base 10 of 8 times log base 10 of 3. That's there. Then to two decimal places, that would be 3.44. Then it says, use a suitable value of X to determine whether the model can be used to predict the median mass of monkeys less than 1 week old. So let's go back to the model. So we had a model for the median mass in kilograms, where x is the age in months. So if we want to predict something less than 1 week old, let's say there's 4 weeks in every month. So if x equals 1 is 1 whole month, we're going to need x equals a quarter to just to have less than 1 month, or less than 1 week, sorry. Or let's say less than 1 week, actually. So let's go slightly smaller than a quarter. Let's go for a fifth. So x equals a fifth, or 0.2. What does that give us for our model then? So it'd be y equals our a value, which was 3.44, plus our b value, which was 5.6 over log base 10 of 8. Times log of 0.2. It was log of x, wasn't it? Let's just check. Yes. Cool, so let's use that now. So I've already got this 3.44 stored. Actually, let's write it out again. 3.44 plus 5.6 over log base 10 of 8 times log base 10 of 0.2. That looks good. So that actually gives us a negative mass. So y equals minus 0.89 kilograms. So not suitable, as it's predicting a negative mass. Or as it predicts a negative mass. Moving on to question 9. It says, find the binomial expansion of 1 plus 3x to the minus 1 up to the power of x squared. So that's going to be using this formula, as it's a negative exponent. So 1 plus nx plus, we want to go to the x squared term, it would be n minus 1 over 2 factorial times x squared. And then for us, n is minus 1, and the x is really 3x. So it's 1 plus minus 1 times 3x, then plus minus 1 times minus 2 over 2 factorial times 3x all squared. So that would leave us with 1 minus 3x. Minus 1 times minus 2 is 2, and 2 factorial is also 2, so that just cancels. And then 3x all squared is a plus 9x squared. Then it says, show that the first 3 terms in the binomial expansion of this form a geometric sequence and state the common ratio. So first we need to actually do the binomial expansion. So let's write it as a power first. So that would be 2 minus 3x to the minus 1. And then the issue we have is we haven't got it in this 1 plus form we have 2 minus something. So let's take out a factor of 2 to the minus 1. That'll leave us with 1 minus 3 over 2x to the minus 1, which is just a half of 1 minus 3 over 2x to the minus 1. And then applying the same formula as before, well, it's a half. Then using the formula, 1 plus minus 1 times minus 3 over 2x plus minus 1 times minus 2 over 2 factorial times minus 3 over 2x all squared. Expanding that out, then we have a half, and then we have this would be plus 3 over 2x, but times that by a half, that would be plus 3/4 x. And at the end, this all cancels out again. But 3 over 2 minus 3 over 2x all squared, that's 3 over 4x squared, times the half again, that's plus 3 over 8x squared. And then we can see the common ratio each time we're multiplying by 3 over 2x. So moving on to the part B, it says it is given that 36x over 1 plus 3x times 2 minus 3x, we can write that as partial fractions. So whenever I'm doing partial fractions, first I'll write these back as a single fraction. So we just have to multiply the top and bottom by whatever part of the denominator is missing. So on the p, that's the 1 plus 3x. So we'd have p times 1 plus 3x over, well, sorry, this will all be over 2 minus 3x, 1 plus 3x. And then the q is missing the 2 minus 3x, so it's going to be plus q times 2 minus 3x. And that's equal to the thing that we started with, so 36x over 1 plus 3x. 2 minus 3x. And then the denominator is identical on both sides. So that means the numerator must also be identical, but no matter what value of x value I choose. So 36x is going to be equal to p times 1 plus 3x plus q times 2 minus 3x. So then we can pick values of x that make this quite nice. So if I make a value of x that makes p disappear, that would be minus 1 over 3. If I do x is minus 1 over 3, we get 36 times minus a third. And that's going to be, the p would disappear then, and we'd have q times, it would be minus 3 times minus a third. That'd be plus 1, so that'd be 3q. So if we do 36 times minus a third, that gives us minus 12. Divide that by 3, we get minus 4. So q is minus 4. Then let's pick a value that makes the q disappear. So if I pick x equals 2 over 3, then we'd have 36 times 2 over 3 equals, we're going to get 3p. And then, so 36 times 2 over 3, that gives us 24. Divide that by 3, we get 8. So p is 8. Then C part 1, it says, using your answers to parts A and B, find the binomial expansion of this. Well, first off, how that relates to part B is it's the same thing, but a third of what we had before. So we're going to do a third of our values for Q and P. So that would be minus 4 over 3. Over the 1 plus 3x. And then we've got a third of the 8, so plus 8 thirds over the 2 minus 3x, yeah. And then thinking about the binomial expansion, let's just write that back as a power again. So minus 4 thirds, 1 plus 3x to the minus 1, plus 8 thirds, 2 minus 3x to the power of minus 1. Well, those are the binomial expansions we did in part A. So here and here. So let's plug in what we got for those. So for 1 plus 3x, we got 1 minus 3x plus 9x squared. We got 1 minus 4 thirds times 1 minus 3x plus 9x squared. Let's just check that's right again. Yep, good. And then we had a half plus 3/4 x plus 3/8 x squared. So that's plus 8 thirds. Sorry, forgotten it. A half. There we go. A half plus 3/4 x plus 3/8. Sorry. Just realised I forgot to square this, didn't I, earlier? That should be 9/8 there, because it's a geometric sequence, obviously, so it should be 3 over 2 each time, so 9/8 x squared. 9/8 x squared. Good. So now we've got to collect these terms together. So we got minus 4/3 minus 4/3 coming from that first bracket. But we've got plus 8/3 times a half. Well, actually, that's just plus 4/3, isn't it? So that would cancel. I can see that. Then the x terms, we've got minus 4/3 times minus 3. And then we were adding 8/3 times 3/4. So that's going to give us a 6x for the x term. And then for the x squared term, we'll have minus 4/3, minus 4/3 times the 9 plus 8/3 times the 9/8. That gives us minus 9x squared on that term. Then C part 2, find the range of values of x for which the binomial expansion of this is valid. Okay, so if we think about what we did here, we had 1 plus 3x to the minus 1, and then we had, so that was from the binomial expansion of that denominator part, and then we had a half of 1 minus 3/2x to the minus 1, when we did that in part A earlier as well. And what we have to remember is for this formula, 1 plus x to the n, when we do that binomial expansion, mod x needs to be less than 1. So for this guy, mod 3x needs to be less than 1, which means mod x needs to be less than 1/3. And for this guy, mod of minus 3/2x needs to be less than 1, which is going to make mod x less than 2/3. So if we want a set of values that works for both, because for this we're using both binomial expansions, then it's going to have to be the first one here, because that's more restrictive, right? It's going to allow for the top one and the bottom one, whereas this one just accommodates this, but doesn't accommodate this. So the final values of x that we can use are mod x is less than 1/3. Going to question 10, it says the function f is defined by this equation here. Determine whether the curve y equals f of x has a point of inflection at the point where x equals 0. Well, if we're going to talk about a point of inflection, we're going to need the second derivative, so let's differentiate twice first. So for the first derivative, we'd get 2x minus 2 sine x. And then differentiating once more, we'd get f double dash of x would be 2 minus 2 cos x. And then let's just check what happens when we actually, it should come out at 0 if there's a chance of being a point of inflection at that point. So f double dash of 0 would be 2 minus 2 cos of 0, which would be 0. That's not enough to say for sure that it is a point of inflection. Though we need to see if it changes signs, if the second derivative changes signs either side of that point. So let's have a look at f double dash of, let's say, minus 0.1 and f double dash of 0.1. So that would be 2 minus 2 cos of minus 0.1. And 2 minus 2 cos of 0.1. Right, well, I can already tell that that's not going to change sign because the cos graph is symmetric, isn't it? But let's just, for the sake of the workings, let's put that through. So 2 minus 2 cos of minus 0.1. That's 9.99 times 10 to the minus 3. And we're going to get the exact same thing because cos of minus is the same as cos of the positive value. So there's not a sign change which is what we need to have a point of inflection. If you think about it, if you have a point of inflection, the curvature changes from curving down to sort of curving up. So we need a change of sign for there to be a point of inflection. So we'll say no sign change for f double dash of x either side of x equals 0, therefore no inflection point. Going for question 11, it says a student states that 3 is the smallest value of k in the interval 3 is less than k is less than 4. Explain the error in the student statement. So the problem is 3 is not included in that interval. 3 is not included in interval, or in the interval, as k being greater than 3 is strictly greater than. So it's not inclusive. If it was greater than or equal to 3, then he would be correct. Okay, then we've got part B. It says the student's teacher says there is no smallest value of k in the interval between 3 and 4. The teacher gives the following correct proof. So assume there is a smallest number in the interval. This is a proof by contradiction then, and let this number be x. Then they say, well, let's let another number y be 3 plus x over 2. So that's the midpoint between the lower bound 3 and this supposed smallest value of x and 2. But that doesn't make sense, right? Because x was the smallest value supposedly, but we just said there's a midpoint between the x value and the lower bound. So that is the contradiction they're asking us to explain. So if 3 is less than y but less than x, then x is not the lowest value. Okay, then it says, prove that there is no largest value of k in the interval. So we can just do the exact same thing, copy the teacher's steps, but adapt it for our problem. So we're going to assume there is a largest value. In the interval k is greater than 3 but less than 4, and we'll call it x again. And then let's suppose we take another number y again to be the midpoint between, but now the upper bound and x, so that's x plus 4 over 2. This would then imply that, well, y is greater than x, but less than 4. But that's a contradiction. As y is in the interval and greater than x. Oops. So that if we've got the contradiction, then we've completed our proof. So therefore, there is no greatest value in the interval. Going for question 12, it says, two constant forces act on a particle of mass 2 kilograms so that it moves forward in a straight line. The two forces are a forward driving force of 10 newtons and a resistance force of 4 newtons. Find the acceleration. So that's just an F equals ma problem, right? So the net force would be 10 minus 4, so 6. and then acceleration is force over mass. So 6 over the 2 would be 3 meters per second squared. Carrying on to question 13, it says a car starting from rest moves forward in a straight line. The motion of the car is modeled by the velocity time graph below. One of the following assumptions about the motion of the car is implied through the graph. So, first option, the car never accelerates. Well, that's not true. That's happening in the first section here where the velocity is increasing. The acceleration of the car is always positive. That's not true because it's staying constant, it's 0, for this section here. The acceleration of the car can change instantaneously, so that is true. So we go, rather than it being a nice smooth change, we've got a very abrupt change here. So it would be the third option. Carry on to question 14. It says the displacement r meters of a particle at time t seconds is r equals 6t minus 2t squared. Part A just says, can we find the value of r when t equals 4? So simply plug in t equals 4. So r would be 6 lots of 4 minus 2 lots of 4 squared. So using our calculator for that, 6 lots of 4 minus 2 lots of 4 squared is minus 8 meters. Determine the range of values of t for which the displacement is positive. So we want to know where r is greater than 0. That'd be 6t minus 2t squared is greater than 0. If I factorize out a 2t from all that, we'd have 2t times 3 minus t. That's just a simple quadratic inequality. If I sketch that, we'd have a root at 0 and a root at 3, and it would be a negative quadratic. Oops. This is r against t. And that's 3 there, and this is 0. And we're interested where it's greater than 0. So it's where t is greater than 0, but less than 3, because that corresponds to this section of the curve here for those t values. Continuing to question 15, it says we've got two forces F1 and F2 acting on a particle of mass 3 kilos, and then we're given the forms of the forces F1 and F2. The particle has an acceleration 4ba, find the value of a. Okay, so this is an F equals ma question, right? If we use the vector form, F equals ma, well, the net force is just F1 plus F2 equals ma still. That would be, as a vector or a column vector, it's going to be a plus 4 and then 23 plus b equals our mass times, so 3 times our acceleration vector 4ba. So reading off the top line, we'd have a plus 4 equals 3 lots of 4b, that's 12b. Reading off the bottom line, we'd have 23 plus b would equal 3 lots of a. So now we've got just a pair of equations we can solve simultaneously. So I'm going to rearrange this guy for a. A is then 12b minus 4. If we plug that into the second guy, we'd have 23 plus b equals 3 lots of 12b minus 4. Expanding that out, we'd have 23 plus b equals 36b minus 12. Yep, that's correct. And then moving the b across and the 12 across, we'd get 35b equals 35. That means b must equal 1. And then going back to a, if b is 1, then a is just 12 minus 4, which is 8. Okay, moving on to question 16. It says an apple tree stands on horizontal ground. An apple hangs at rest from a branch of the tree. A second apple also hangs at rest from a different branch of the tree. the vertical distance between the two apples is d centimeters. Okay, so let's say we've got an apple here and an apple here, and we know this distance is d. At the same instant, at the same instant, both apples begin to fall freely under gravity. The first apple hits the ground after 0.5 seconds, and the second apple 0.1 seconds later. So they both eventually hit here. This one takes half a second. If it's 0.1 seconds later for the other one, it takes 0.6 seconds. And we both know they're accelerating freely under gravity, so acceleration is just 9.8. It says show that d is approximately 54. Okay, well, let's label the remaining distance. Let's call that h, and then just write down what we know for both. If the acceleration is constant, then we know that we can use SUVAT for both equations. So SUVAT, let's call this apple 1, this apple 2. So 1, 2. So apple 1 has to go a distance of d plus h. It starts from rest. We don't know the end velocity. We know the acceleration, if I could define down to be positive, we know it's 9.8. And we know the time is 0.6. And then for apple 2, we do SUVAT as well. We know the distance is just h. Initial velocity is 0. Final velocity is, we don't know. Acceleration is 9.8 again. And then t is 0.5. So for our second apple, we have everything we need to work out h. So let's go ahead and do that. So for apple 2, if we want something without v in it, that would be s as ut plus a half at squared. So that would tell us that s, well, the u is 0, so it's going to be a half times 9.8 times a half squared. So that's 0.5 times 9.8 times 0.5 squared. So that gives us, as a decimal, 1.225. Then we have everything we need to work out d plus h in the first apple, and if we have h, so this was h, then we could find d, couldn't we? So for apple 1, we'll do s as ut plus half at squared again. That's going to tell us that d plus h is a half times 9.8 times 0.6 squared. If I go back and just turn this into a 0.6, that's 1.764. So we know d plus h is 1.764. And then the d we want is going to be minus the 1.225 we got for h. So d would be 1.764 minus the 1.225. Take that away. And we get 0.539, which is about 54 centimeters, 0.539 meters. Moving on to question 17, it says a uniform rod is resting on two fixed supports at points A and B. A lies a distance of x meters from one end of the rod, that's labeled already. B lies x plus 0.1 from the other end, that's also labeled. The rod has a total length of 2L and a mass of m kilos. The rod lies horizontally in equilibrium, as shown in the diagram below. The reaction force at the support on the rod at B is twice the reaction force of the support on the rod at A. Show that L minus X equals K. Okay, well, it's a uniform rod, so let's label all our forces on. So we can put mg in the middle. So this distance would be L minus x. And this distance would be L minus x minus 0.1. Good. And then we also have the reaction forces at A and B. So let's call that RA and RB. And we're told that the reaction force on the rod at B is twice the reaction force on the rod at A. So let's just relabel that actually. Let's just call that 2 lots of RA. Okay. So first off, if we just look at the forces up and down, if it's an equilibrium, we know 3 RA must equal mg. Or in other words, RA is a third mg. And then to get the distances into this, we're going to need to use a moments equation, right? So let's take moments about, where should we take the moments about? Let's take moments about A. So if I take moments clockwise about A, then we've got a rotational, clockwise moment from due to mg, so that would be L minus x times mg. And then if I take away the counterclockwise moment of the 2RA, so that would be 2RA, well, the full length is 2L, so we need to take away the x and the x plus 0.1, so 2L minus the 2x and minus the 0.1, and then the clockwise minus the anti-clockwise, that must equal 0 if we're in equilibrium. That's the same as saying the clockwise equals the anti-clockwise, if you want to think of it that way. And then we just got to expand this out here. So let's actually plug in RA. So RA is a third mg. So L minus x times mg minus, this would be now 2/3 mg 2L minus 2x minus 0.1 equals 0. Oops, got my g there. Then we can cancel off mg everywhere, dividing everything by mg. And then let's multiply everything by 3. So that's going to put the 3 over here, essentially. So get rid of that and puts that there. And then just expand everything out. So that'd be 3L minus 3x minus be 2 times 2L. That would be 4L. We'd have minus 2 times the minus 2x. That would be plus a 4x. And then we'd have minus 2 times a minus 0.1. That'd be plus a 0.2. That's all equal to 0. Let's simplify this down now. So if I collect the L's, we're going to have minus L. And we'll have plus x plus 0.2 equals 0. And if I bring that over the other side, we'll have it as L minus x equals 0.2. So our k must just be 0.2. Moving on to question 18, it says a particle is moving in a straight line through the origin O. The displacement of the particle r meters from O at time t seconds is given by this equation here, where p and q are constants. When t equals 3, the acceleration is minus 1.8 meters per second squared. Show that q is approximately 82. Well, we need to use that information. If we're going to get the acceleration, we're going to need to differentiate from displacement to acceleration. That's differentiating twice. So let's do that. So first off, the velocity function, if we differentiate once, p is a constant, so that disappears. 2t just becomes 2. And then we would have plus 0.2 q e to the minus 0.2t. We differentiate once more to get acceleration. The 2 would now disappear, and now we'd have minus 0.04 q e to the minus 0.2t. And we know when t equals 3, acceleration is minus 1.8. So we could write minus 1.8 equals minus 0.04 q e to the minus 0.2 times 3. So q then must be minus 1.8 all divided by minus 0.04 e to the minus 0.6. So if we plug that in the calculator just to check it comes out, so minus 1.8 all over minus 0.04 e e to the power of minus 0.6, which is 81.99. So yeah. (81.99), so approximately 82. The particle has an initial displacement of 5. Find the value of p. So that means r equals 5. Oh, sorry. R equals 5 when t equals 0. If we use that information, we could say 5 equals p plus, well, the 2t would go to 0, so it would just be minus q e to the minus 0.2t, or e to the 0. So that's just 1. So then we would get p is just 5 plus q. So we can just add 5 onto this. Gives us 86.99, or let's say 87.0 to 3 significant figures. Oh, so 2. Yeah, to 2 significant figures, it's also 87. Carrying on to question 19, it says a toy shoots balls upwards with a vertical velocity of 7 meters per second. The advertisement for this toy claims the ball can reach a maximum height of 2.5 meters from the ground. Suppose that the toy shoots the balls vertically upwards. Verify the claim in this statement. So we have a ball starting with an initial velocity of 7 meters per second. And we want to find its maximum height. Well, at the maximum height, we know the end velocity would be 0. And it's moving freely under gravity, so the acceleration would just be 9.8. So if the acceleration's constant, then we can just use SUVAT. Let's do SUVAT. I'm going to define up to be positive. So I would like to find S. U is 7 going up, so that's positive. V is 0. A is 9.8 down, so it'd be minus 9.8. And I don't need T if I just want S. An equation without t would be v squared equals u squared plus 2as. So s is going to be v squared minus u squared all over 2a, which would be minus 9.8 squared over, sorry, not 9.8 squared, sorry, minus 7 squared over 2 times minus 9.8. So that would be minus 49 over 2 times minus 9.8 is 5 over 2, which is 2.5 meters. So we verified the claim. State 2 modeling assumptions made in verifying the claim. Well, we assumed it's moving freely under gravity, so that means there's no drag. So no drag. Acting on the ball. Let's see, what else have we assumed? Well, I suppose we've assumed that it does start from the ground level. It could go a bit higher, I guess, if the toy had some dimensions, and it wasn't sitting on the ground. So ball starts at ground level. So moving on to 19b, it says, in fact, the toy shoots the balls anywhere between 0 and 11 degrees from the vertical, and the range of maximum heights is now given by this. But can we find the minimum value of the range of heights? So if you think about it, if we are shooting our projectile at an angle to the vertical, theta, then we want that angle to be as large as possible. So that theta is 11 degrees if we're considering the minimum. And then we can resolve that velocity. If I want the vertical component, that's the adjacent, and that the starting velocity is still 7 from before. So this would be 7 cos theta, or cos 11 in my calculation I'm about to do. If we do our SUVAT, so S is what I would like. Now the vertical velocity, we're just splitting the motion up into the vertical and horizontal. The vertical component is 7 cos 11. The final velocity is still 0, if we're thinking about the maximum height still. And the acceleration is minus 9.8 down to the ground, and t we don't know. So if we want s, so an equation without t, that's still v squared equals u squared plus 2as. So the s is still just v squared minus u squared over 2a, which is going to be minus 7 cos 11 all squared over 2 times minus 9.8. So plugging that in, we're going to have minus 7 cos 11 all squared over 2 times minus 9.8, which gives us 2.4 to two significant figures. Carrying on to question 20, it says two particles P and Q are moving in separate straight lines across a smooth horizontal surface. P moves with constant velocity 3i plus 4j, and Q moves from position vector 5i minus 7j to position vector 14i plus 5j during a 3-second period. Show that P and Q move in along parallel lines. Well, this is how P is moving. To get the direction of movement, we can just think about the displacement of Q. So the displacement for Q would just be, if we take the 14.5 and we take away the 5 minus 7, so that would be 9 and then 12. And we think, well, 9, 12 is a multiple of 3, 4, isn't it? It's just 3 lots of 3, 4. So that means they must be parallel. Their movement must be parallel. Therefore, moving parallel. So carrying on to part B, now it says Stevie says that Q is also moving with a constant velocity of 3i plus 4j. Explain why Stevie may be incorrect. So I'm gonna guess Stevie's done like a distance time calculation, but it doesn't, that would only be a good thing to do if it wasn't accelerating. So we don't know the boat isn't accelerating. Sorry, the particle isn't accelerating. So he's wrong because Q might be accelerating. Then it says, part C, a third particle R is moving with a constant speed of 4 meters per second in a straight line across the same surface. P and R move along lines that intersect at a fixed point X. It is given that P passes through X exactly 2 seconds after R passes through X. PR are exactly 13 meters apart 3 seconds after R passes through X. So that's a lot of information. And it's talking about how P moves. So let's first write that down, and we need to visualize this. So P, velocity of P was what? Sorry, 3i plus 4j. And so yes, we to show that they're moving perpendicularly. So let's just let's draw a diagram, just assuming they are for a minute, to think about how to see this. So let's say this is the direction of VP is going in this direction. This is the P, and then R is doing this, and this must be point X where they cross, right? So if we think, let's say t equals 0 as when R is at this position, X, then we've got two different scenarios going on. We've got to consider when t equals 2 and when t equals 3. So let's think about when t equals 2. What do we have? So at t equals 2, we've got p is at X, and R has passed through by has been traveling past through it for 2 seconds. So we've got our boat P, which is at X, and R has traveled to here, which is at a velocity of 4 meters per second. So that would be a distance of 8. And then let's think what happens a little bit later at t equals 3. So now if this is point X here, R will have traveled a little bit further. So that would be now another 4 meters. So going to R, this would be 12 meters. And we can think about how far P would have traveled. So P would have traveled for 1 second through R. So this vector here would be just timesing this by 1, so 3i plus 4j. And let's get that as a distance, as everything's in terms of distances. So if we do Pythagoras on that, the magnitude of that is 3 squared plus 4 squared, which is 25, and then square root, so that's 5. So this distance here from X to P at t equals 3 is 5. And then we're told that P at this time, the distance between P and R is exactly 13 meters. So then it says, show that P and R move along perpendicular lines. Well, if that's true, then that means this must be a right angle, and this must be, if it's a right angle triangle, it must satisfy Pythagoras' theorem. So let's check that, right? So 12 squared plus 5 squared, that would be 144 plus 25, which is 169, which is 13 squared. So therefore perpendicular, as it is a Pythagorean triple, or as it satisfies Pythagoras' theorem. Carrying on to question 21, we've got two heavy boxes M and N are connected securely by a length of rope. The mass of M is 50 kilograms, so I'm just going to mark that on. That's 50g. That was 60 degrees. And this is 80 Gs for the weight of N. The rope is passed over a smooth pulley at the top end of the slope, so that N hangs with the rope vertical. The boxes are initially held in position with the rope taut and running parallel to the line of greatest slope, just parallel to the plane. The boxes are released, M moves up the slope and N descends with acceleration A. The tension in the rope is T newtons. Explain why the equation of motion for N is 80g minus T equals 80A. So that's just applying F equals MA. If we label on the other forces, so for N, it's just T going up, and I'll do this quickly as well. We've got a reaction force and tension on M. So that would just be, the net force would be 80G minus T is the net force, and 80A is just because it's 80 kilos times acceleration. Then it says show that the normal reaction force between m and the slope is 25g. So that's just us like resolving that. So if I draw another sketch here, we've got our block. This angle is 60, a reaction like this, and we've got what was this? This was 50g. Oh, oops, 50g. So if we resolve to the perpendicular, this angle is also 60 degrees. So this side of this triangle would be 50g times cos 60. And then if we think it's if it's an equilibrium in this position, then we know r minus 50g cos 60 is the net force, and that must be 0 if we're in equilibrium. And then cos of 60 is just a half. So we get r minus 25g equals 0, so r must equal 25g. Then it says the coefficient of friction mu between the slope and m is such that mu is between 0 and 1, inclusive. Show that a must be greater than or equal to this. Okay, so we have to think about the acceleration. So to get that, we're going to need to consider the equation we had before for acceleration, as well as the motion of m. So there's a frictional force acting on m as well. So if we draw ourselves another diagram, thinking about the block on the slope, we've got this force going up for t, we've got the frictional force pulling us down, as well as a component of weight, pulling us down the slope. So this component here would be the weight, which is 50g, 50g sine 60. So writing out an equation of motion for this guy, we would have T minus the friction, which is just mu times the reaction force. And we actually worked out the action force earlier, didn't we? Reaction force is just times 25g. And then we've got also subtracting the weight going down the plane, so that's minus 50g sine 60. Sine 60 is just root 3 over 2. That would be 25 root 3 g. And that equals our 50a. And we also had from before that t was 80g minus t. Sorry, 80g minus t equals 80a. So let's write that down as well. And we want to talk about just the acceleration, really. So let's add these equations so we can just purely talk about acceleration. So the tensions cancel, that's why we're adding. We'd have 80g minus 25g times mu minus 25 root 3g would equal 80 plus 50 is 130a. And we can divide everything here by 5, actually. So let's go ahead and do that. 80 divided by 5 is 16. So we have 16g. 25 divided by 5, that's 5. So minus 5g mu. And then we've got another minus 5 root 3g. And then 130 divided by 5. That's 26. A. So if we rearrange now for A, actually let's factorize out the g on the left first. So we've got so we've got g times 16 minus 5 mu minus 5 root 3 equals 26a. And just divide that by 26 now. So a would be equal to g 16 minus 5 mu minus 5 root 3 over 26. And if we think about it, the acceleration is going to be a maximum when mu is 0. So a max is when mu is 0. That means a must be greater than... Sorry, we want the minimum, don't we? Yeah, we want the minimum if we want to think about what a must be bigger than. So the minimum would happen when mu would be 1. So if mu is 1, then we'd know a must be greater than or equal to g times 16 minus 5 times 1 minus 5 root 3 all over 26, which is what they asked us for. A must be greater than or equal to 11 minus 5 root... Sorry, that's a minus sign there. Minus 5 root 3 g over 26, which is what they asked for. Then it says, state one modeling assumption you have made throughout this question. I don't think we included, or the question didn't include anything about the rope, which is like a classic thing to include here, right? So let's just check that. No, so what we've done when we combine these equations for a and t is we assumed that the rope is inextensible. That means the accelerations must be the same. You could also say, if you wanted to, that the rope is light. That means the tensions were the same everywhere in the rope. That's the end of the video, guys. I hope you found it helpful. If you did, please drop it a like, that helps me out a lot, and consider subscribing to the channel to find out when I release new videos. Thanks, and I'll see you in the next one.